Hi everybody, I thought I'd do quite a short video to talk about how to write a multiplexer in Go, because it's a question which I sometimes get asked. The basic idea, start by writing a test case so you can see what's going on. We have a basic idea is we have a number of channels going into something and we want them all to be merged into one channel. So you can think of a chans being a list of, let's call them in chans. It's a list of channels which you can read from. Let's make them strings so we can get some more information. And let's just put something in these channels. We'll just build up the test case, then we can write the code to solve it. So for I is equal to 10, I is less than 15, I plus plus, in chans guys append, in chans make chan with an I. Okay, good. Let's have a func make chan which takes an integer and it gives a chan string to it, gives a chan string back. We're just going to have a ret make chan string. Let's have a go func here so we can put things into the channel. Let's just do it like this. So we just going to put an infinite number of things into the channel. Return ret. And we're going to close the channel when we leap out of this for. So close ret. Okay. So n equals rand.int n of e. If let's add 1 to it. If n equals e, then we're going to close the channel and return. So let's put the close here and return. Don't need it here. And let's put something into the channel saying we're closing. So ret goes to format.sprint f. Come on, let's have that one. Yep, there it is. Sprintf closing chan closing, and the channel we're closing is channel I. Otherwise, we're just going to put a ret goes into format.sprintf chan d value d. And this is just an I and an n here. So now we have our channel which we've made. We're making 5 of these, and we're starting them off running within chans. And we want to make a mux, a way to merge all these channels. So package main, let's call it mux, and it takes a list of chans, just in chans, which is going to be something like this. T, it can be anything, so let's make it variadic. And what it returns is a channel which you can read from, which is a channel of t's. Okay, so we have to create a return channel. Ret make chan t. We're going to return it. So now comes the question: what do we do to read from each of these channels? You have to be quite careful about how to do this to make sure there won't be any runtime conditions, any race conditions. Any times that it can get stuck, or where by bad timing things can be repeated, or things will go missing. And what we're going to do is we're going to create one thread per channel, which just reads from the channel until the channel ends, and we're going to count when the channel ends. So we need to have Go gives you something from this out of the in the standard library out of the box, which is called a wait group. Sync.wait group. can add a certain number to it, which is going to be the length of the in-chans. And then each time an in-chan closes, we're going to subtract 1 from this. So we're going to have a go routine. So for in-chan, in range of in-chans, we're going to start a go routine. Let's make that the channel as an argument. In-chan, let's call it in-chan here as well, so we don't get confused. We have to do this because in Go, so this little gotcha with Go, this is a pointer to something, this in-chan. So the next time you go through the for loop, it will get replaced. So if we don't give it as an argument to the Go function, whatever we'll be referring to inside the Go thread will get updated to be whatever it's referring to in that particular loop iteration. It's a gotcha for Go. Have to remember to do that. Okay, so go func in-chan t. So basic idea is for lm range in-chan, it's going to push the lm to the to our ret-chan, and when the in-chan closes, we're going to a wg.done. Okay, and then here we're going to start one more thread which waits until the wait group is down to 0, it's been subtracted down to 0, and then we'll close the outgoing channel. So func here, we don't need to give it any arguments, and we just do a wg.wait. So now we're waiting for all of these things here to be done, and then when this gets down to 0, we can then do a close on the ret channel, which will cause the reader of the ret channel to be notified that the channel is now closed. Okay, let's go through this once more to make sure it's clear. We have a list of incoming channels here, and the idea is to put all of the contents of the incoming channels into one outgoing channel. So we're just merging the incoming channels to one outgoing channel. To do this, we make an outgoing channel, which is good, which is also what we're returning at the end here. And then the question is, how do we shut the outgoing channel? That's one of the main questions. And the idea is that if all of the incoming channels close, then the outgoing channel should also close. But first when that happens. So Go provides us with something called a wait group, which you can think of as an integer protected by a mutex if you want. I'm not sure how it's implemented. And the wait group, it has these methods on it, add and done and wait, and that's about it. And add allows you to add a certain number to it, in which case we're adding the length of the number of in channels which come into it. And then every time an in channel closes, the only way to get out of this for loop is if the in channel closes. This is one of the many meanings of for in Go. The first for here is a loop over the various in channels. This is an explosion here. I'm not sure what it's called in different languages. It means that there's a variadic function which can take a different number of arguments. So let's use that here. So our mux is equal to mux in chans ... That's a variadic function. So you can think of this ... splitting the array apart, the array we built here, to produce in-chan 1, in-chan 2, in-chan 3, and this is the elements which are then put together here to make in-chans. There's no particular reason to do it this way. I could have just given it the list, but I think it looks nicer, it looks a bit neater. And then let's train the channel here. So for lm range mux, let's just print it, t.logf mux has read slm. Okay, that should do it. So where are we? So we've got this for loop here, which is a standard for loop over a list. So this could be thought of as a for each over in-chans, over this slice of channels, this list, array, slice, whatever you want to call it. In different languages it's called something different. In Go this would be a slice. This is a position reserved for the index. The full for syntax in this case is index and then element, but we're not using the index, we just put an underscore there, leave it out. And then with each element, we are starting a lightweight thread, a green thread, a Go routine, whatever you want to call it, a thread where all the information about the thread is stored on the heap and not on the stack, and is managed by the runtime of the language and not by the operating system. And we're just reading in an infinite loop. This for means an infinite loop over a channel. So we have two different meanings of the word for here. For means an infinite loop over the channel until the channel closes. And when the channel closes, which it does here, in our test case, we close the channel there. When the channel closes, then we go into wg done here, and then the function ends. We fall off the end of the function. And what the weight group done does is it reduces the value of the weight group by 1. So we add, let's say, 10 to the weight group, and this case will be 5 to the weight group. Then this one will be weight group minus 1, be 4, 3, 2, 1. And this wg weight waits for the weight group to fall to 0. Okay, so we can test this. Mux, I think we called it, didn't we? Yeah, test mux. And let's see what it does. Ooh, that didn't go well. What am I doing wrong? Mux test go 14.9, undefined mux. Didn't I save it? Oh, I haven't saved it yet. Okay, that would explain it. And now it runs. Cool. You can see the channel's closing. Let's have a little bit more information about when the channels close. So I've said they should close when the value of the random number generated is the same as the index of the ID of the channel. So let's put this no matter what here, so we always see that message. And let's run this again. There we are. Yes, you can see the channel 12 is closing here because it received a 12. Channel 13 is closing because there was a 13 as a random number came in. So you can see it all closes. It all closes perfectly. Let's have a little bit more information to make sure that's clear. In the test, let's write that in the test. There's a little bit of information here for element range mux tlux. Let's add here t.log mux closed. And we can maybe, if we want, even add it here. There was no point to add a logging message to this particular. No, there's no point to add it. Okay, let's control. Okay, now we've got lactose. And that took a lot longer this time. It's a random thing. Okay, so this explains how to write a multiplexer in Go. It's not much code. Thought I'd just show you that, and have a nice day.